And remote sensing is the process of creating geospatial data, of accessing geospatial data, getting that data from the real world. And you gather that data remotely. So there's the remote and remote sensing. You don't physically interact with the location of interest or the object of interest, but you gather that information from a distance. That's the remote part. And then the sensing part means that you're using, you're using a sensor or a instrument to gather that information. So maybe the most basic instruments that we would use to gather information from a distance would be our senses, our eyes and our ears. But really the science of remote sensing is concerned with technological techniques and methods using using sensors attached to airplanes or satellites or drones, and these sensors are capable of taking a photograph. That's one form of sensing, or you could have a hyperspectral, multispectral sensor that's keen into different parts of the electromagnetic spectrum that may or may not be visible to our eyes. There are even sensors that can see underground. And so you're picking up that information remotely, and then you enter this middle phase where you're maybe processing the data, interpreting it, cleaning it up, and this is where a lot of the techniques and technologies of remote sensing come into play. But I'm not really going to get into that today. Just know that the take-home message here is that remote sensing is about gathering geospatial data from the real world and using a sensor to do it, and to do it remotely. So, and then that geospatial data that we gather has all sorts of applications. Everything from city planning to social sciences to navigation to natural resource management. I'm not sure what everyone's majors are, but I mean, what kind of majors do we have in the room right now? What are people studying? What might you use GIS data for? Anyone want to offer there?
I'm studying water science.
Water science, yes. That's a major, GIS all over the place.
So, my dad had a friend with the game and parts of it at Camp Pendleton here in California. And one of the things he does is he would do aerial surveys of the wildlife population in the area.
Yes, that's exactly right. And that's really the world that I'm coming from, is the wildlife ecology, natural resource management, where you can assess species habitat, you can track where they're going with a radio collar, and then look at how they're using resources. And so yeah, absolutely. Any others?
Yeah, I'm studying fisheries and wildlife, and I'll soon be getting a double minor in mathematics and criminal justice.
Ah, excellent. Yeah, the wildlife ecology needs more analytically inclined people. That's great. And yeah, there's a whole world of spatial modeling, and you can convert, I'm sure, as you're aware, a mathematical model. You can do that in GIS, all kinds of great things there. Very cool. All right, well, that kind of leads into my next point here, where when I think of remote sensing or remotely sensed data, I tend to think of things like this. Instead of a Valentino's menu, I think of maybe an aerial photograph of a landscape. And this is a photograph, a remotely sensed image of a Nebraska landscape. I think this is somewhere in eastern Nebraska. And it, I believe, was obtained, from a sensor attached to a plane. So they do flyovers, and we're going to be looking at some similar data here, but they do flyovers every few years, and then get these images, relatively high resolution images, this geospatial data that then can be used to develop things like, here's a land cover map from that same area. So basically, these different species of plants, different surfaces are reflecting energy or reflecting light in different ways, and you can pick up on that information, get that information from the remotely sensed data, and then use it to classify the image into something that makes sense for how we view the world. So here we see, oh yeah, we have the pond, and there it's surrounded by fields, and there's some grassland and some trees. So again, it's moving from the real world, and then there are all sorts of applications for something like land cover data. And you see this image is made of pixels, and each pixel gets assigned a value. Is this a row crop pixel? Is this a water pixel? But this image at a higher resolution is also made of pixels, just like your TV screen or anything else. And so all these pixels contain information, and that's really what this remote sensing is ultimately picking up on. So how's that for a crash course on remote sensing? Like I said, you can take the course if you're interested in these processes where you have different platforms and sensors. You have different corrections for you need to correct for the fact that sometimes clouds are in your way, and all a whole other list of things, and then interpreting and classifying this information. We'll go over a little bit of this, but the main point here is geospatial data from the real world sensed remotely. That's remote sensing. And I mentioned this a little bit already, but a lot of my background is in like the field of landscape ecology, and remotely sensed data is just foundational to all the analyses we do in landscape ecology, but it's an entire science. So I thought at this point we would together see how this goes, but I will work through just showing you some examples of what's out there as far as remotely sensed imagery, and there's no real format for this. I'm gonna do some I'm going to go into Google Earth Engine, but if you see something that you're interested in or have a question, please feel free to stop me, and we'll just work through it together. So I mentioned this Google Earth Engine several times. What is Google Earth Engine? Well, we can start by Googling. Actually, Google is trying to distract us with the World Cup, but we'll get distracted together. Oh, the US is up. So there's our 15-second distraction, but just Google Earth Engine, and you'll see what I'm talking about here. So Google Earth Engine is both a data repository. They ingest all sorts of data, all these national data sources, this remotely sensed data from different places. I mentioned, you can find water data sets, fire data sets, forest data sets, just about anything you can imagine here. And so you see here they have satellite imagery, and then you can do analysis on those for real world applications. And when you run a job here, the job goes to Google supercomputers somewhere, and you have all this power of Google at your fingertips. So it's really actually pretty amazing. The same things that you could do on the supercomputers here at UNL, a lot of those same things you can, if you have a Google account and a web browser, and you're willing to do some light coding, you have all this analytical power at your fingertips and all these data sets. So So they mentioned the data sets here. We'll get into that in a minute. But I think I was reading a while back that Google Earth Engine has ingested 5 petabytes of imagery. And I don't even remember petabyte. What is a petabyte? Is it, somebody jump in if they know. Petabytes to gigabytes. So 1, 2, 3, so that's 1,000,000 gigs. So they're ingesting millions of gigabytes of just this satellite imagery and other types of data sets. And so, first of all, if you're interested in a Google Earth Engine account, you can click here to sign up. And I'm actually already have an account, so it gave me that error message, but you can sign up with a Gmail account and have access to all this. So how about some of these remotely sensed data sets? Well, you can click on the data sets tab and you can view all the data sets. You can see some of the different ones that are available here. They mentioned the satellite imagery, Landsat, again, 1972 through to present. These satellites have been orbiting the Earth and taking pictures at 30-meter resolution. And so you see we're currently on Landsat 8. There were some neat ones. You could literally here search for, we mentioned we had water. Yeah, so global inland water data sources. Basically anything global, they have just all kinds of data on it. I saw this one earlier. This is very interesting. So nighttime light data. This is remotely sensed. And so if you click on a data set like I just did, it gives you some information about it. This is from NOAA. And they also have some code to get you started in their code editor. And so you can copy and paste in your code editor, or you can just click this button and it opens up for you. And I won't go through all the specifics of how this works, but basically there are a lot of great tutorials. They have very basic tutorials for introducing you to just the JavaScript or Python scripting you need to access this data. But let's look here. So we're going to look at nighttime light values. It looks like it's set to 2010 for the year 2010, and then they had the code already. I'll put a couple of slashes to block this out so it doesn't zoom us to somewhere random. But then we can hit run, and there's the data of nighttime lights. So you can see how much light certain areas of the country or in the world are giving off. You see the clear line here between the eastern and western United States. As we move into the Great Plains, it's much less populated, but you do see the major cities. Even if you can turn the layer on and off over here. Even if I zoom into Nebraska, there's Lincoln. Here we are in Lincoln. And then Omaha. And so anyway, you can easily filter. What if I want to look at 2012 instead? You can do that, or look at a different time frame, and you can again see those different values. So you can do this with a sample code for just about any data set. They'll get you started on it. But I mentioned imagery, and I mentioned the Landsat data. Another, they have the Landsat data available in all its forms here. But one I want to look at, it's a little higher resolution, is NAPE imagery, and this is from for just the U.S. and it's collected every few years by the USDA. And so we can open this up in Code Editor, this NAPE data set. Give it a minute. There it is. All right, and can zoom into a Nebraska landscape. Let's change the dates just to make sure. They only collect it every few years, so I'll just move that from 2014 to 2018, and we'll get the imagery from that time frame. Whoops, it zoomed me. There's that function. Where did it zoom me to? Long Island, looks like. But so that it has imagery for everywhere, but we're going to go to Nebraska, and it'll take it some time to load. But I'm going to take you as an example to an area of Nebraska, and you can, here's the imagery coming in. Now this is 1 meter resolution data. So here you see this is from the NAEP imagery is collected by a plane every few years. And so I'm gonna zoom into this area right near North Platte, Nebraska. By the way, I'll post all this data online if you're ever interested in getting into it. But this is an area where you have somewhat of a simplified landscape. You have rangeland. This is called the Lusk Canyons of Nebraska. And there's a lot of rangeland where they do cattle ranching, but they also have a lot of cedar trees that are starting to grow in the landscape. And that's kind of a problem for wildlife and for cattle ranching because not a lot of grass grows underneath the trees. But this is a fairly simplified landscape for some of the activities we might do, like classifying an image, because we just have grass and trees. And so the goal here is to extract a piece of this landscape and to then read it into ArcMap and classify it. So we already kind of know what is in the landscape. But the cool thing about Google Earth Engine is if you want data for a specific area, you can pull it from Google servers, and you can just you can draw a feature here just like you would. So I clicked on this little rectangle, draw a rectangle. And let's just zoom in. I don't want too big of an area because you don't want the data to be super massive. But let's just say for this area, here's my area of interest. And this is the data we'll be working with, data from this area in southwest Nebraska. And I'll click on this little button and I'll name it Lusk Canyons. Okay. Now I have a whole set of images that are really being summarized here from between 2014 to 2018. And what I want to do is just isolate one of them. I don't really care what it is, but I did mention you have to just maybe do some light coding. But there are great tutorials for that. So I'm just going to, essentially what's going on here is I'm saying, give me the image in the middle, the median image. I could have put first in here, I could have put last, but however many images are in this 2014 to 2018, it might just be one, but give me the median. And so that'll get me one image. And then there are a whole list of functions that they have for you here, but the one we're going to focus on is exporting an image to Drive. So this is, they give you instructions for the coding here, and again, this will be made available to you. I'll save this script. And we'll post it online, so if you ever want to go, you can read it in and customize it for yourself. So let's call the script Lusk Canyons, and we're gonna do this export image to Drive. And that's the cool thing about this, is that you can just pick any spot on the planet, draw a circle around it. You can also load your own shape files, and you can export it to your Google Drive account. So that the image is dataset 2, and again, that's the middle image from this image collection. And so I'll just call this, give it a name, Les Canyons, and I'll send it to a folder in Google Drive. And I'll send it to a folder called Nebraska Imagery. You have to put these names in as a string. And then the scale or the resolution of the image, you know, you have low resolution images that are blurrier and they have large pixels, and you have fine resolution images like this one. The resolution here is 1 by 1 meter, but you have to remind it. Oh, and I want the region, the area I want, again, is this polygon here that we created. So what we're telling it to do is give me this data, NAPE imagery, for this polygon in the Les Canyons, send it to my Google Drive folder called Nebraska Imagery, and give me a resolution or a spatial scale of 1 meter by 1 meter. So we hit run, and then you saw this tasks tab lit up. Okay, the job is ready to run, and so you click run, and it says, okay, this is the name of the task, and we're sending it to this folder. Here's the scale, all those parameters we sent, and set it to run. Now we just wait for it to extract this information, and it should pop up here in this file if everything goes well. So maybe I'll take a break right here while it runs. Does anyone have any questions or about any of this or specific data sets?
Can you hear me?
Yes.
So for the people in, you can actually get this from, you can extract the code from ArcGIS, and you can, from the base maps, from using that, and you can actually, instead of being in a Google Earth engine, you can do the same thing in ArcGIS using that if you have your own separate encoder tool.
Yeah, say that again. Say that at the end if you have your own what?
You can do this in ArcGIS. You can extract the code from the base map for the area that you want to do, but you have to have your own coder tool in order to do that. Yeah,
excellent. Yeah, thank you. And that is another great point, is that you can, yeah, there are other ways to access this data. If you would like to stay fully in ArcGIS, for example, instead of crossing over between you know, programs and platforms, and you can get the information you want there. But ArcGIS has great online tutorials for doing that too. So that's an excellent point, that you know, you could also download this data from the USDA website, and even the Nebraska Department of Natural Resources has data online too. So I think that's such an important point about you know, spatial analysis in general and using the different platforms, is that if you can, you don't have to learn to do it a specific way, but if you can learn to teach yourself, that is a valuable skill, you know. And a lot of times, you know, Googling is just a great way to do that, and you'll come on to online tutorials or courses. But I think that is such an essential skill, and you can do it. You can teach yourself to do it. So if you can teach yourself to learn new techniques and new ways of accessing that, that's just valuable. So yeah,
REPL,
excellent point. Anything else?
REPL.it. That is at least the one I frequently use to test my code. And you can go there and you can write your own scripts, and then you can test them out there. And it has instructions step by step for how to do that. And I posted that in chat too. So.
Okay, yeah, thank you. All right, so that is another avenue. Now this has finished running. You see the checkbox there. And so let's go to this folder, and and you can download the image. And then, like you mentioned, if you choose to cross over programs or work in ArcGIS, or I actually work in R a lot, statistical programming, and so I will read it into R as well. But today we're going to just go through a few. We're going to pull up this information in ArcGIS. And I will note too that yeah, there may be instances where certain platforms are better for different different activities. So you can open ArcGIS and click on the Add Data button, and then you may have to connect to a folder to, it might be in your Downloads folder, for example. But if you, mine is in my Downloads, you can open that that information or that layer, and there it is. So there's the Loess Canyons, again, a pretty simple map, pretty simple landscape. Okay, and so then the next thing that we're going to do is just briefly touch on image classification. So essentially, when you're talking about classifying things, there are a number of different algorithms for classification. There are a number of different approaches to it, but essentially the main idea here is that you're grouping things. And in this case, we're grouping pixels according to the information contained in those pixels. So, so what we're going to do here in ArcGIS is first train an algorithm with a sample of pixels, and then we're going to have that algorithm make predictions for every pixel in our landscape. So when you look at this landscape, you can see, we can visually see some areas are trees and some areas are not. And those, trees and different species of plants are reflecting light in differently, and that information is contained in these pixels. If we zoom in really far, you can see these individual pixels, where some of them might be tree pixels, or some of them might be more grassland pixels. And what we're going to do is group these pixels into classes. And we'll just see how it works here. So the first thing that I'd like you to do is click on the Customize tab, and then click on Extensions. And we're going to make sure that you have the Spatial Analyst extension enabled. It doesn't matter if other ones are enabled too. So enable Spatial Analyst and click OK. Click Close. And then, now that that's enabled, you're going to we're going to click on the Customize tab and hover over Toolbars and go down to Image Classification. So that brings up this Image Classification toolbar. And what we're going to do, we have all these different approaches to classification: supervised classification, unsupervised classification. They're all different algorithms, and we'll just use the maximum likelihood, which is very powerful and commonly utilized in statistics. That's the algorithm, but we need to train that algorithm with some data. We need to say, like, okay, this is a tree and this is grass, so now you know what they look like. So you click on this shape, and you can choose any shape you want, and you can draw a circle, for example. And so let's draw a circle over some trees, and then click on this Training Sample Manager. And so you say, okay, what is the thing I just drew a circle around? And we'll call it trees. Okay, now maybe let's do some grass. This looks like a pretty grassy area. So there's our grass. It's going to sample those pixels, and then maybe we'll do, this area looks a little bit like it's just bare ground. Bare tracks, bare ground. So maybe we'll say, just as we'll try to do those 3 classes, and then maybe I'll try to just do some more tree areas here. Actually. Whoops, let me redo that here. We'll just do trees, grass, and we'll try to get some of that bare ground a little better. And you do want to keep in mind there are appropriate sample sizes for, you want to get a good sample of pixels. And there are some recommendations for that, but I think just to demonstrate the technique, so we have these different areas to train the algorithm. And now let's click this create a signature file. So this is, just basically that data that's used to train it. And so you just save that as a signature file. And now we can close this box and go back up and click on this classification. So we can choose these different classification algorithms. Let's just do maximum likelihood. And so we're going to input as a signature file that training data we just entered. And then we can, for our output, this is going to be the result of the classification. We can navigate to wherever we'd like to put this. And so I'm going to name this as a TIFF file, and this will, if you don't name it as a TIFF, it'll be fine, but I have a long name here, and ArcGIS has lengths on the names for some of these extensions, and so TIFF will just get you around that. So we'll do a TIFF file, and then we'll just, again, you can play with these settings, but let's turn it loose. So now with the data, all right, look at that, there's our result. So with the data we used to train it, we said, given that these tree pixels have certain reflectance values, and these bare ground pixels have other ones, and these grass pixels contain this information, it extracts that information from those pixels and uses it to make predictions. So number 1 was trees. Let's just change, you can click on these and change the color just to make it a little more interpretable. And let's see that our number 2 was grass. I'll maybe have that be a lighter yellow. And then finally our bare ground, let's have that be brown. You can turn the layers on and off. There you go. You see we got a pretty good, it's not perfect, but there are formal ways for evaluating the accuracy of your classification, but you can see the general concept there that we have this remotely sensed data collected with a sensor on an airplane. We accessed that data in Google Earth Engine, extracted a small piece of it, read it into ArcMap, and then used the information contained in the pixels of that image to classify this relatively simple landscape. So then, of course, and maybe I'll break there. Are there any questions or comments? Okay, well, if not, we could go all the way. And one of my favorite things about ArcGIS that you avoid with the programming languages and such is that you can it's really easy to click around and explore, which is really nice in certain cases, and and I like making maps in here too. And so I switched the map from data view to layout view, and then I zoomed into it, and we can insert. You always want a north arrow, of course. There's our north arrow, and we can play around with these different different settings and things, but essentially we can export a map here. And of course, then the other thing, we'd want a scale bar and a legend, so we can look at distance here. So there, see, it's not a very big area. And just quickly add a legend here. We just want the predicted map to be in here. Can name it whatever we like. We'll call it land cover classes. Give it a border and a white background. And we can name them whatever we like here. Ungroup them. And of course, the trees correspond with number 1, the grass with number 2, and the bare ground with 3. Those are the predictions. So trees, grass, and bare ground. We can regroup these, and I won't take the time to perfect all this, but then the nice thing about ArcGIS here is we can export export our map. And we'll call it Les Canyons Prediction. And you see it's at a certain resolution as well. So then we can look at our map, and there you have your map, put it in a presentation, or whatever you like to do with it. So that is, that's really, I just wanted to introduce you to those tools today and those different options. I'll just zoom back out here. If you have any questions, like I said, I'd encourage you to get in touch with your instructor Getachew or me or one another, or consider continuing to take some remote sensing courses in the future. So that's really all I have for you today. If you do find some utility in this approach at all, feel free to replay the video or email me with questions. But I'd be happy to take any other questions or open it up to you, Getachew, if you had any comments for the class. But that's really all I had for today.
Thank you, Dan. Can you hear me?
Yes.
Thank you so much for your excellent presentation. This is really a good eye-opening, and then some of the concepts may not be easy now, but when you go through, it becomes easy. And if you have any question, please forward to Dan. Thank you, Dan, again. This is excellent presentation, and we love to have such kind of guest lecture. And if possible in the future, by next week, we may have another one. But for your time, really, we appreciate and we like your presentation. Thank you so much. And group, if you have question, please forward for Dan.
Yeah, hopefully it's a good, just a good overview of what's out there and just some of the things that are possible.
Thank you. I don't really have any questions, so I guess I'll be signing off unless is there anything we need to know further about this module or anything that we've learned today?
Say it again. I didn't get your question.
Is there anything else we should look into before we go further in the module or before we leave this meeting?
Thank you, Diana. Maybe, actually, this guest lecture is to have some practical use of the remote sensing. And we had the actual remote sensing module 9. So I just invited Dan to share his experience, because he's one of the researchers here in our campus and he became willing. So he has very limited time and he has to go out in the field. So he said today is a convenient day, and then that's why we just arranged it for today. But we just started module 9 yesterday. So if you are somewhat not clear what is being discussed today, that's okay. We will post it by tomorrow. And the first thing is just cover module 9 properly. And then there is a lab exercise, the same as what he just went through. And then you see the video, the lab video, and then you follow the lab instructions. And then after, just practice what Dan gave us today. And that's what is expected. And there is no exam from what he discussed. The exam will be from the module 9 and module 10 that we had.
Okay. Well, anyway, thank you for your time, Professor Dan. I think I'll be signing off if there's nothing else you'd like to talk about.
No, thank you. And yeah, if we'll, like he said, we'll also post the data online too. So even that image that I exported, if people don't want to, if you don't have a Google account, don't want to go that route, but you'd still like to look at it in ArcGIS, we'll post that image, and so you can practice classifying if you'd just like to cut to that step, or if you would like to explore more, that's fine too. So, but thank you for your time.
Okay, thank you. Bye.
Okay. Can you hear me?
Yes.
Okay. I missed the first 2 minutes of this video because I was looking at the wrong email. Could you go over, sorry. Could you go over how you got that Google image, or how you imported that again? If not, I'll watch it later, but I didn't know if you had time to go over it.
Absolutely. Yeah. So does anyone else have anything before we dive back in, or because I'm happy to do that. So everyone else can feel free to stay and watch if they like, or to go. But let me share my screen with you. So what we talked about was, we talked about the basics of remote sensing. Mm-hmm. Just being essentially, when you really boil it down, it's about getting information from about the real world and making it geospatial data. And to do that, we use sensors, and we do it remotely. So it's remote because you're not in direct, contact with the area or object you're interested in, and it's sensing because you're using a sensor, some sort of technology to get that information. So I gave the example that you could consider our senses, our eyes and ears, as sensors for getting information from a distance. But really, when we talk about it in remote sensing, we think of sensors and cameras and things on satellites or airplanes even. And
like drones now?
Yes, drones, absolutely.
Okay.
That's a new area of research. I was just involved with that very thing with a group. There's some groups here at UNL who are, you have the fixed wing drones that, fly, in a straight line a little faster. And then you have, I forget what they're called, like the little, like little helicopters. And
yeah,
exactly. You could mount a sensor on a drone to pick up, all this type of information, even information that isn't visible to our eyes. You could key into different parts of the electromagnetic spectrum. And so, yeah, that is this whole, science of remote sensing, innovations in that technology and in processes for, processing, interpreting, measuring the data. So yeah, that's the whole, there are whole journals and on that subject and whole courses. I mentioned that, the name of this course is this lecture is Introduction to Remote Sensing, but there's actually an entire course offered here at UNL called Introduction to Remote Sensing, and I'd encourage people who are really interested to take that.
How small can a sensor be then, if it can fit on a drone? They can be pretty tiny.
Yeah, that's I don't know how far they've pushed that limit, but obviously fairly small. And then some of these drones can even do things like, say you're surveying a wetland. A lot of my examples are from natural resources or agriculture. Say you're surveying a crop field. The drone can land and pick up a water sample, for example, but then also have this imagery that it's, collecting along the way, this geospatial data. So that's the new kind of a new avenue. But you have on these planes, then you have these multispectral, hyperspectral imagery. They can do all these crazy things. So you probably do have somewhat of a trade-off there. If a drone can carry it, it maybe can't do everything that the sensor mounted on a plane could do, for example. But to get to your question, we looked a little bit at Google Earth Engine as a data repository, and I use it all the time for analysis, actually. Because you can tap into, their supercomputers to do things that it would take, literally months for even a powerful machine, desktop machine to do. But Google Earth Engine is essentially, they've ingested all of the Landsat data and all these global data sources. They have satellite imagery and they have functions that, you do have to do some light coding, but you can do spatial analysis yourself. But they have all these data sets that you can access. And the one that we did was imagery from, and this is US government data. USDA collects this every few years, but NAEP imagery. And so they fly with a plane over the country and they collect 1 meter resolution data. And so you have a description of the data set here. So it's housed, within Google Earth Engine. And then you have, go ahead.
What did you click to get there when you're in the Google Earth Engine to do that search?
I clicked on, so I was all the way back here and I clicked on data sets. I think I view view all data sets. You
Gotcha.
see that.
Okay.
And so, so you can go to any data set and they give you some, I'll click on it here again, they give you some sample code to, do you see where I'm at now?
Yep.
Okay, and so you could search any data set, you know, there are water data sets, fire data sets, you know, climate, all kinds of stuff. And then you can open, you know, it in their code editor. So I click there, and then you have this, code that pops up, and you can store your own scripts, you can load your own shape files, but you can also just draw your own shape files. So if you want data from a specific area, you can just draw it. And so, but here's their sample code, and so you see that I'm going to back this up, this date range. So I want all the NAEP imagery from 2014 to 2018. It might actually only be one image. Then you click run, and I'll zoom in a little bit, but it's loading and it'll print that out. But I went to a landscape near North Platte, Nebraska. This is called the Lusk Canyons. Okay, here it's coming in now.
Could you zoom in all the way onto like a property and use that?
Yeah, absolutely.
Okay.
This is 1 meter resolution data.
Okay.
So you can see like individual trees. And this is the Lusk Canyons in Nebraska. It's a big ranching landscape, but they've also had trees really start to increase. Cedar trees are spreading a lot there, and so that's been kind of a concern. But I picked this just because it was kind of a simple landscape to do that classification on.
Mm-hmm.
The cool thing is that you could import your own shapefile if you were interested in a specific area, but you can also click over here on this draw a rectangle or draw a shape. So I'm going to draw a rectangle and say, like you said, this could be a property boundary. You could trace a property boundary or load an asset. You know, you could load an asset of a shapefile basically of a property.
So you're basically treating it kind of like ArcGIS, like right now on Google, kind of.
Yeah, it's another platform for you can load ArcGIS shapefiles in here, but then there was just and this will be posted in we'll post all this script online. And so what I'm just doing here is this could be a whole set. This is a collection of images, but I just need to select out of that a single image because that's all we're going to export. And I just chose the median, so I want the image in the middle. I could have this be the first or the last or whatever. But then they have this function, and this is under the Docs tab is their functions. And so you can export the image to Google Drive. And so it goes straight to your Gmail, your Google Drive account. So you type in that function.
So then when you put it into ArcGIS, is it like a JPEG or is it like an actual, or is it, what is it?
This is a TIFF file. So you could, yeah. And so anyway, we'll post the code, but we exported the image. The image is dataset 2, and you can give it a name. And then you can tell it which of your Google Drive folders you'd like it to go to. And so here's my Drive folder, Nebraska imagery, we'll say. And then the region, so this has all of the NAEP imagery for the entire US, but the region, we just want this little slice. And so then you say, just give me this polygon we drew. And then the scale is the resolution that you'd like it at, and it comes in 1 meter. So then you just enter the information into that function, and you hit run, and then this tasks bar lit up here. And so then you go there and click, and it gets ready to do what you told it to do. And so now it's exporting to my Google Drive folder as a TIFF, and that's primarily what they work in. You know, it was brought up too that there are ways for doing, I mean, you could download this data set from the government website. You can access this information even in ArcGIS too, but this is just one way that I work with a lot for these large data sets and these, you know, these big data, especially if you're doing analysis. So there, it exported it. It's all done. So now it should be there in this folder. Yep, there it is. And then you can just download it from your Google Drive. And I did mention it is a GeoTIFF, or that's what they call it in R. And so I can add that then just like you would any other raster.
Oh, so since it's a raster file, does that mean it doesn't have a coordinate system? So you don't have to worry about matching everything to this?
No, it does. And so the coordinate system, so if you right click on it and look at the properties, it is geo-referenced, and so it comes in this WGS 1984.
Okay.
And so right now the unit is degrees. And so you can do it, you know, you can use the project raster tool to match to something else or to match something else to it, and treat it just like you would anything else. So yeah, it does have a, you know, it does have a coordinate system. So that's essentially what we did. Just looked at, you know, there's all sorts of stuff that's, you know, they have all kinds of data sets. I mentioned that I think that they said that they have like 5 petabytes of satellite imagery, so they're just ingesting everything global, you know, like, and then you could, you know, access it in these other avenues, or you could just, you know, have, this is sort of a one-stop shop. Not that there aren't other versions of that, but this is one of them.
This is just kind of like using Google Maps on your phone. There's obviously other maps, but this is kind of the go-to guy. Okay. Yeah,
and so the interesting thing about it that you have to remember is that they are the they're the server and you're the client. And so all the information, if you load something on there, I think you can get 250 gigs of storage of your own. So if you want to put your own shapefiles on there, but it's all on Google's server. And so you send them jobs and then they send you back the results. So your computer shouldn't do any work, or it should do very little work. Their supercomputers are what are doing the work, and then you send them instructions and they send you back the results. So it's kind of, I mean, in some ways an old model of, you know, like if you had to send a job down, you know, in the 1970s down to,
right. That makes sense.
But so that's what's going on. But so for that reason, you use their functions, and you don't, you know, you do some light coding, but it's in, you know, they have options to do it in JavaScript, which is just, you know, web programming language, but then also Python. I just use Java, and they have great tutorials for teaching you how to do it. I mean, I think there are advantages and disadvantages to it. If you're wanting to work with global data, you know, or large data, if you need land cover data for the entire US, you might consider this, you know, especially if you want to do analysis on something. But for other applications, or if you need, you know, they might not have a local data set, you know, their stuff is more global and national. And so it just depends what you need to use it for, but it is one option.
Awesome. That makes sense. That sums up kind of what I was looking for. Thank you.
Yeah, no problem.
Thank you, Dan. This is excellent, and you revised already. Thank you so much.
Yeah, thank you. Anything else, or can I end the meeting for all of us?
End it.
All right. Well, thank you again.
Thank you so much, Dan, and I think we benefited a lot. Thank you for your time and for your expertise. Thank you so much.
Thank you.